Welcome to Chapter 7. In Chapter 7, we're going to be talking about logarithms. And logarithms are the inverses of exponential functions. So it's how we can solve exponential functions, solving for that exponent when the exponent is a variable. Now, we need to know the definition because that's going to help us rewrite. So log base b of y, and that's how we read that, log base b of y equals x. And that's true if and only if b to the power of x equals y. So that's kind of telling us how to rewrite these. So when you rewrite these, what I do is I write them using a little kind of I call it the swirl method. I got this from another teacher. You start at the base b to the power of x equals y. And that's kind of how you rewrite it, from logarithmic to exponential form. And then you can go from exponential to logarithmic form. You would do log, and then you start at the base. Log base b of y equals x. And that's how you can kind of switch between the two forms. So writing an exponential form, so if we have y equals 2 to the x, in logarithmic form, log base 2, so log base 2 of y equals x. And there it is in logarithmic form. Let's go to the other exponentials just to keep practicing it. Log, start at the base. Log base 1/2 of y equals x. Log base, so start at the exponent. Log base 7 of y equals x. Log, start at the base of the exponential. Log base a of c equals b. And that's taking it from exponential to logarithmic. From logarithmic to exponential, start at the base. 3 to the y equals x. 3 power of y equals x. Start at the base. 5 to the y equals x. And there is our rewritten forms. Let's look at a few more. So we're taking these from logarithmic and writing them in exponential. So start at the base. 2 to the third equals 8. And that's a true statement. And you can kind of check, wait, 2 to the third does equal 8. That's a good one. For this one, start at the base. 1/4 to the negative first equals 4. Now to write this properly, we need that fraction in parentheses. To the negative first equals 4. And that's a true statement. Once again, the rewrite, start at the base. F to the h equals g. And there's our rewritten. Let's go to the next page. We're evaluating. So what we're going to do, let's say that equals y for all of these. This is going to make it a little bit easier for us to evaluate. So what we have, I'm going to take this from logarithmic and write it in exponential. 3 to the y equals 9. Because what we're looking for is we're saying, all right, which exponent is 3 to the power of equal to 9? And what happens is 3 squared equals 9. You get 9 equals 9. So y equals 2. That's the missing exponent. That's what we're solving for. So here we would do 4 to the y equals 256. So you can kind of do a little guess and check. 4 to the fourth equals 256. So that means that y equals 4. That's the missing exponent. Log base 64 of 8 equals y. So 64 to the power of y equals 8. Now when we're going from a bigger number to a smaller whole number, we want to think root. What root of 64 equals 8? Well, the square root of 64 equals 8. Square root is the same as raising to the 1/2 power. So our exponent, our missing exponent, our value for y is going to be 1/2. 7 to the y equals 1. Now, the only way to get from a whole number or any number to 1 is if your exponent is 0. So y is 0. Number 8, rewrite 2 to the y equals 1/8. When you're going from a whole number to a fraction, think negative exponent. So now 2 to the third is 8, but we want a fraction. So we would need a negative exponent. So 2 to the negative third is 1/8. So y equals -3. Log base 5 of 5 equals y. 5 to the y equals 5. Now to get the same number, 5 to the first equals 5. So y equals 1. And that's evaluating. We're writing them in exponential form and finding the missing exponent. On your calculators, you have a button that says log. That button is what's called the common log, and that's log base 10. So log base 10, the common log is also written just as log of x. So you can see here for number 10, there's no base shown, so that base is 10. So using your calculator, just hit log of 1,000, and you're going to get 3. And the reason it is, that's the log base 10 of 1,000. So it's 10 to the y equals 1,000, and 10 to the third is 1,000. We're still finding that exponent, but the calculator did it for us. Log of 0.85. So you use your calculators. We're going 3 decimal places. You're going to get -0.071. Now what we're doing here, this is the log base 10 of 0.85 equals y. So that's 10 to the y equals 0.85. We're going from a whole number to a fraction, a decimal. So our exponent needs to be negative. And that's what it is. We found out that 10 to about the -0.071 is going to be pretty close to 0.85. It's not exact because we rounded. And now for number 12, type it into your calculator and you're going to get 0.903. So what we have here is the log base 10 of 8 equals y. So it's 10 to the y equals 8. We're going from a bigger number to a smaller whole number. Think fractional exponent, think decimal. And if you check, 10 to the 0.903 is going to be a number very close to 8 because we have a rounded answer. But you could find those using your calculator. Okay, thank you for your time. It's all about knowing how to rewrite logs into exponential form and from exponential form into logs. When we're solving these or evaluating these logs, we're finding out what the missing exponent would be in that exponential form. Okay, we'll talk about properties of logs in the next section. Thank you.